Today we're going to continue the second part of Chapter 5, Section 1, which is simplifying trigonometric expressions. So I'm going to begin with example number 6. It says simplify. Hint, simplify by combining fractions. Begin with letter I. I am adding two fractions together, and notice everything is already in terms of sine and cosine. Nothing is squared, so I can't think about a Pythagorean identity just yet. So when I add two fractions together, I must have a common denominator. Now my common denominator is going to be a combination of my denominator 1 plus sine x and cosine x. So I'm going to go ahead and rewrite this expression as two fractions with my common denominator, which will be cosine x times 1 plus sine x. And cosine x times 1 plus sine x. Okay. Now, the first fraction, cosine x divided by 1 plus sine x. In order to make this have the common denominator, I need to multiply the numerator and the denominator by cosine of x. Now, multiply across. Cosine x times cosine x is cosine squared x. And cosine x times the quantity 1 plus sine x gives us our common denominator. Okay. Now on the right side, I need to multiply the numerator and denominator by 1 plus sine x. Okay. My denominator gives me the common denominator. Now in the numerator, I have to FOIL. Okay, so don't forget, when you FOIL, you distribute the 1 to both terms and sine x to both terms. I'm going to complete this above, and then I'll simplify it within my expression. So 1 times 1 is 1. 1 times sine x is 1 sine x. Sine x times 1 is sine x. Sine x times sine x is sine squared x. If I combine like terms, I have 1. Sine x plus sine x makes 2 sine x plus sine squared x. I have two fractions with a common denominator. Now I'm going to combine these as a single fraction. And when I combine them as a single fraction, I have my common denominator, cosine x times 1 plus sine x, as the denominator, and I combine like terms at the top. There's nothing that's alike, so I'm going to copy down my cosine squared x. And I have plus 1 plus 2 sine x plus sine squared x. Okay. Now, this is where it can get a little bit tricky, but there's a couple ways that we could approach this. Okay. One way that we could approach this is to recognize and use Pythagorean identities. Notice in my numerator, I have a cosine squared x plus a sine squared x. Well, this is a Pythagorean identity, and cosine squared x plus sine squared x is equal to 1. So I can replace both the cosine squared x plus the sine squared x with 1. And this would be equal to cosine squared x plus sine squared x is 1, and I bring down my plus 1 plus 2 sine x. And in my denominator, I still have the cosine x times the quantity 1 plus sine x. I'm not going to distribute the cosine x in the denominator until I have to, if I have no other moves to make. I can combine like terms in the numerator. 1 plus 1 is 2. So I have 2 plus 2 sine x, all divided by cosine x times the quantity 1 plus sine x. Now, in my numerator, I have two terms. Both of them contain a 2. So I could use the 2 and factor out a greatest common factor. Okay. So in my numerator, if I factor out a 2, 2 divided by 2 is 1. 2 sine x divided by 2 is sine x. And in my denominator, I have cosine x times the quantity 1 plus sine x. Now I have a common term in both the numerator and the denominator. I have 1 plus sine x in the numerator. I have 1 plus sine x in the denominator. So I am left with 2 divided by cosine x. I can break this fraction apart, okay, by breaking apart the numerator and denominator, and 2 is 2 over 1, and my cosine x in the denominator is 1 divided by cosine x. Okay? So what I did is I took my fraction and I broke it apart to 2 separate fractions. Now 2 divided by 1 is 2, and 1 divided by cosine x is its reciprocal, secant x. So my answer is 2 secant x. Okay, let's try letter J. I have cosecant x divided by 1 plus secant x plus cosecant x divided by 1 minus secant x. Okay, now I could put everything in terms of sine and cosine, but before I do that, I'm going to go ahead and combine the 2 fractions together and see what I can come up with. Okay, so if I wanted a common denominator, I would find that by multiplying my 2 denominators together. So I would have 1 plus secant x times 1 minus secant x. I guess I need to redo this so it looks a little nicer. Give myself more space. Again, I have 1 plus secant x and 1 minus secant x. Okay. Now, in my numerator, I need to go through each of my fractions and determine what I need to multiply numerator by in order to get my common denominator. So for my first one, I have 1 plus secant x. That means I need to multiply top and bottom by 1 minus secant x. I'm going to go ahead and just keep it as it is, and I'll change it later if I need to. So I have cosecant x times 1 minus secant x. And the second fraction, I need to multiply by 1 plus secant x over 1 plus secant x to get the common denominator. So I have cosecant x times 1 plus secant x. Okay. Now I'm going to go through and I'm going to combine this as a single fraction. So there's several things that's going to happen in this next step. Now 1 plus secant x times the quantity 1 minus secant x is a difference of 2 squares. And if you FOIL or distribute, you're going to get 1 minus secant squared x. Again, take 1 times 1, 1 times negative secant x times 1, and secant x times negative secant x. It will reduce to 1 minus secant squared x. Okay, in the numerator, if I distribute the cosecant x times 1 is cosecant x. Cosecant x times negative secant x is a negative cosecant x secant x. Okay. Move to the right side, cosecant x times 1 is cosecant x. And cosecant x times secant x is a positive cosecant x secant x. Okay. I can simplify in the numerator. Notice I have a negative cosecant x secant x and a positive cosecant x secant x. Okay, those go away. It's 0 when you add those together, and I'm left with cosecant x plus cosecant x. That is equal to 2 cosecant x. Okay, in my denominator, I have 1 minus secant squared x. Now, we have a Pythagorean identity that's tangent squared x plus 1 is equal to secant squared x. Okay, I need to try to maneuver this equation so that I can have 1 minus secant squared x on one side of the equation. So the first thing I'm going to do is subtract tangent squared x from both sides. So I have 1 is equal to secant squared x minus tangent squared x. And then I can subtract secant squared x from both sides. So I have 1 minus secant squared x is equal to negative tangent squared x. So I can replace 1 minus secant squared x with negative tangent squared x. Okay. Now, just as I did in the previous two problems, I'm going to separate my fraction so that I have negative 2 cosecant x all over 1 times 1 divided by tangent squared x. Okay. Now I can't do anything with the negative 2 cosecant x. That's going to remain. But 1 divided by tangent squared x is equal to cotangent squared x. Okay, so this expression is equal to negative 2 cosecant x cotangent squared x. Okay, I would like for you to try letter K. Okay, when you are finished with letter K, I would like for you to pull up the solution and check your answers. And make sure you write down any questions you would like for me to address either before school, during SRT, or during class. Good luck.